So today we're going to do quiz 9.3 and now a card trick I'm going to show you folks during break. And then we're going to go over two sample means that are dependent, and also confidence intervals for that. And then we're going to review a few of the concepts for these chapters. Due today you have Math 8.3 and also Lab 8 is technically due today. Thursday you'll have 9.1, 9.5 due today. So we don't have class on Thursday, but you do have homework due anyways, still. And then next Tuesday you'll have Math 9.3 due. And then next Thursday 9.4, which is short. And then we'll have our exam on Tuesday, May 2nd.
On Canvas it said that 8.2 was due on Thursday, I thought.
I changed it.
Oh, you did?
Yeah, it should be like this.
The lab says it's due Thursday.
Yeah.
The lab says it's due Thursday?
Yeah. The lab 8. Yeah.
Oh, Lab 8 says due Thursday. That's fine. Okay, so we'll bump that. We can shift those over. I'm okay with the lab being a little bit later. I don't want the homeworks to be a little later because the homeworks go later, then you bump up against the exam. So Lab 8 can be due on Thursday, that's fine. And then the next Thursday, it'll be firmly due. Thanks, I'll change that on my PowerPoint for next time. So let me actually do that now real quick. So this is due Thursday, and this is due also Thursday. Great. The Advanced Mathematicians was due last Tuesday, so today is the last day to get that done for full credit. So make sure you get that Advanced Mathematicians. It's a really easy 10 points extra credit. Get that done today. You know there's no class on Thursday. Also, if anybody wants to W this weekend, for those watching at home, this is the last week. I can still W until this weekend, but you have to let me know by Friday if you want me to do that by email, and then I'll have proof and I'll give you a W. So W is withdraw. Everyone knows that. Okay. The exam is on Tuesday, and I'll do a review for you folks Monday from 7:20 to 8:30 next door in 2416. But next week we're going to be doing just review all next week, so we may not even need it. We'll see how that goes. Oh. Hold on. Was this the one that was on?
Yeah.
Okay. Okay, good. Just making sure. That one was for Monday, Wednesday, which if you are Monday, Wednesday, then that one would be the one you want to get. Financial Literacy Club. I think it's super important. Who's here has ever heard of an IRA? And who's ever heard of a Roth IRA? So Roth IRAs are really important, I think, for all of you to be doing one. Really, until you're like 60, you should be doing Roth IRAs. Basically, it allows you, it's retirement fund, because for you folks, Social Security ain't going to be around. It just isn't. But it allows you to save money in this retirement fund, and it grows. The nice thing about the Roth IRA is you pay taxes for it now, but if you put in, say you have $5,000 you put in for like 5 years, you have $25,000 in there. In 10 years it becomes 50, another 10 years it becomes 100, another 10 years it becomes $200,000. All that growth, you pay no taxes on any of it. So that's kind of the nice thing about a Roth versus a traditional IRA. The traditional IRA will grow, but when you pull it out, you're going to pay taxes on all of that. So I'd much rather pay taxes on $100,000 now, and then not pay any taxes on the $400,000 when I take it out. So it makes sense. So that's why I think a Roth IRA, especially when you're younger, is such an important thing, because as it grows and doubles, you pay no taxes on all that growth. The other nice thing about a Roth IRA is that if you have an emergency in your life, most of these things, the retirement funds, you can't touch them until you're 59 and a half. But the Roth IRA, the money you put in, the part it grew, you can't touch that. But the initial money you put in, you can pull that out anytime without penalty. So that's why another good reason why it's kind of a really good and kind of critical one. But this Financial Literacy Club, they will talk about that and other things that people need to know. Right? If your parents don't tell you, I have friends my dad instructed me well on how to plan financially. If your parents didn't do that, and a lot of my friends' parents didn't, this is an important thing to kind of know and get a handle on. It's just a new club that just started. And you can text to 81010. Text them at LPC FLC for Financial Literacy Club, and it'll add you into their group, your phone, and then they'll send you text messages when they're meeting and stuff like that. All right. Exam 3. Yours is going to be Tuesday, May 2nd at 4 o'clock. It's going to cover chapters 7, 8, and 9. Study guide is in the back. Again, it's the booklet plus the sheet. You want both of those. And then for the exam itself, you're going to need your magic formula sheet, your half-page of written notes, TI calculator, and optionally a T-table or scratch paper. There are some fixes. So I would grab your study guide, and it's the 5th page, I think it is, 5th piece of paper, 4th piece of paper, number 19 and number 20. It's the 4th sheet of paper. We're going to look at some changes to it. There's some typos on that one that I didn't fix. And I'm just going to put it down here. Okay. So number 19, does everyone have this one? Mm-hmm. So smaller than 65% should be changed to be different than 52%. Here, I'll show you what it should be. So, so the things that are circled should be changed, and then see where it says according to your sample, cross that out. The things circled should be changed to the following. Different than 52%, and the alpha should be 0.05. So make those changes. Those are typos that I foolishly did not correct last semester. And then you have that stuff in the middle that you're going to be crossing out. So you're going to cross out the according to your sample 30 out of 54% of voters. So again, that smaller than 65 becomes different than 52%, I believe. And the alpha should be 0.05. And then A and C, where it says another, don't cross that out. I simplified this question. I changed it to make it just a little simpler and not this extra layer of complication. Good? Everyone's got those done? Okay. And then the next one, number 20, change it to 21 so we don't have two 20s. So it's going to 21 first and then 20. Alright, so that first one should be make it 21 instead of 20. And there are a couple of changes to that one. The main one being that you're just crossing stuff out. So you're going to cross out, there we go, that whole sentence. And then the two anothers, cross those out as well. All right. Good. So get back to our regular stuff. Another thing I wanted to talk about a little bit was expert students. So when I looked at people's exam wrappers from the beginning of, you folks did an exam wrapper from the first exam where you reflected on it. Looking at yours and other previous semesters, a couple things stood out. First of all, students who did well did not just cram the last few days before the exam. They studied a little bit throughout the whole month leading up to it. And also they tend to look at how things were connected or related instead of just, how do I solve this? Right? Because how do I solve this? That's just memorization. And the memorization is really easy to misunderstand what a problem is asking for and kind of the right figure out what the right approach is to solve it. Finally, they're more likely to have a study session or study group where they could ask questions of classmates and discuss problems and solutions. I think that's really important because, again, talking and explaining to other people, we talked about this at the beginning of the semester. The way the brain works is you have these things called mental structures, which is how you store information into your brain. And the clearer that mental structure is, the easier it is to store into your long-term memory, and the easier it is to retrieve stuff from long-term memory. And explaining things to other people is harder because it forces you to create a clearer mental structure. Right? It forces you to have a clear sense of this concept. Also, organizing information into a table does the same thing. Forces you to sort of sort things out and figure things out. So those are super important for that reason. Those are all skills that you should use and take with you as you go into a 4-year college. So part of what we're doing here at this 2-year college is preparing you to be a good student in the future. Right? And those are some things: having study groups, organizing your material or your information. And the curve of forgetting. Curve of forgetting is this. Oh wait, it's not this. Math anxiety first. We're going to talk about that. How about Jason? Go ahead.
You want me to read it?
Yes, please.
4 out of 5 students with math anxiety are average to high math performers. Rather, math anxiety is linked to higher activities in areas of the brain that relates to fear of failure before a math task, not during it. This fear takes up mental bandwidth during a math task, creating, for example, my feeling suddenly blank and unable to think.
Right. Have people ever had that, right? You kind of panic. Or you have to talk in front of people and you get all nervous and your brain goes, shh, right? Mm-hmm. Keep going.
There aren't math people and non-math people, only those who work through the challenging lessons and those who surrender too soon.
Right. So very often, math anxiety is panic before the test, not during the test. Because you're thinking about the test, you're thinking about how you're going to do on the test. Don't focus on how you're going to do on the test. Just focus on how can I prepare for the test, and prepare. Because if you do the best test prep you can, then that's all you need to ask of yourself, right? Your best is all you ever need to do in life, ever. Don't worry about what you can't do or what you can't control. Life will work that way. Like, when I was a student at Berkeley, I couldn't get myself to stay awake and do my homework, or I couldn't get my butt over into class to attend it, so I got kicked out. And you know what? In the long run, it was what was meant to be, and my life turned out great. So just kind of do the best you can do, whatever that is, and it'll work out, however it does. But don't waste time panicking about stuff you can't control, because that is a true waste of your time. All right. Good. Curve forgetting. Yes. So what happens is we learn something, we totally get it, and then we have this curve where if we don't see it again, we totally forget about it 4 or 5 weeks later, and we have to relearn it all over again. But if you just spend a little bit of time the next day, so I suggest the next day after lecture, you got to eat lunch or eat dinner. Just while you're eating lunch or dinner, flip through your notes and review them, 10, 15 minutes, and it just re-ups it up in your mind and reinforces all those neural pathways and helps you remember it better. And then kind of re-ups it, and then a week later when you're doing your homework, it'll take you just a few minutes to kind of flip through and say, oh yeah, that's what that is. Oh yeah, I remember that. And then, bam, you can do your homework, right? But that re-ups it again. And then, it's even stronger. So then, 3-4 weeks later when you go to take the test, take you another 5 minutes to kind of say, okay, what is this? And kind of go through it. Oh yeah, that's right. Okay, yeah. And then you can kind of do your practice problems for the exam and you're all good to go. All right, so that 15 minutes, 5 minutes, 3-4 minutes, that is less time than if you ignored it and then try to cram it all in at the end and you have to relearn it all over again. And you won't know it as well either. So that's why this kind of a little bit every day, or not every day, but a little bit the next day, and a little bit a week later, and then a little bit a few weeks later after that. That's how you learn best, right? Just kind of re-upping this memory of understanding, just, and it won't take that much longer, right? All right. We're going to jump back into chapter 9. What's the goal of the experiment or survey? If it is a confidence interval, in other words, if we want to estimate our mean or proportion, that's a confidence interval, that's chapter 7. If we want to know if our population differs from the general population in some way, we can do a hypothesis test, that's chapter 8. And then there's having two samples and seeing if two samples differ, two populations differ from each other in some way. That is chapter 9, that's what we're doing now. These are not my slides, so I'm going to be a little bit rusty with them, but it's important ideas, so I do want to talk about it a little bit. So with two samples, remember there's two things we know about each person. It's what group they're in, and also the actual value we're trying to study, the proportion or the mean. So when we pick people, we can either pick our people randomly or not randomly, like they're not sampled randomly, like I'm just going to take my stat class because you're all in my stat class. Or like what we did for our sample, right? We did not sample randomly. We picked 4 people we knew to create our sample for our project. Remember that? Give me nods of understanding. Yes? Okay. So that was not random sampling. And then for chapter 9, we're going to split them into 2 groups. If we split them into 2 groups randomly, that's good. If we don't split them into 2 groups randomly, maybe we can't. Like we're going to have cats and dogs, right? You can't put a cat into the dog group or vice versa. So that would not be random. So those are the 4 possibilities going on. So if you do randomly sample people and you randomly put them into one group or the other, like we did with the female undergrads, right? Female undergrads are randomly sampled, put randomly into one group or the other one. One group was told, do your best. The other group was told, try to improve in the number of sit-ups you do by 10% each day. And then a week later, they checked to see, and this one group had improved a lot, and this other group did not improve as much. That is true cause and effect, because you randomly pick people and you randomly assign them to one group or the other. So you can say that what they're told caused them to increase their number of sit-ups. So that's the ideal situation. You can actually draw a cause and effect. However, if you randomly sampled them, but then you didn't put them into groups randomly, like I randomly sampled dogs and cats, and I found that the cats were blah, 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 whereas the dogs were blah, blah, blah. It might be some third thing causing, it's not just that they're cats and dogs, it might be some third thing that's causing this to happen. So that's, and I can't control that because I can't split them, differently. So that is subject to so you can make an inference, but you can't say which one causes which. It's sort of like, you folks remember the one we did with students, where they looked at oh yeah, right. So they randomly sampled students, sure. But then they looked at whether students asked questions or didn't ask questions. And then what their grades were at the end. They didn't have any choice of whether, they didn't say you students ask questions, you students don't ask questions. They let them sort of self-select whether they ask questions or not, and then checked out their grades. The problem is that, yes, you could say that students who asked more questions got better grades. You cannot say which one causes which. It might be that if asking more questions leads to better grades, or it might be that having a higher grade makes you more comfortable, so it leads to you asking more questions. You don't know which one causes which. So in that case, where you don't randomly assign people to one group or the other, then that you can make an inference, you can make a correlation, but again, you can't say which one causes which. The last ones are sort of a little bit rougher, because if you did not pick them randomly, then there's potential for sampling bias, right? And if you, which we're going to learn about later on today, and also if you didn't assign them randomly, then there's potential for other confounding variables going on. Okay. see how we're doing with this. We'll turn that off. And then the other thing I want to talk about quickly with chapter 9 stuff is pointing out the fact that in chapter 9, it's how these two samples relate to each other. So we're not comparing them to a number. Chapter 8, we're comparing them to a number. We're saying, is our proportion less than 17%? Or is my mean greater than 53.6? Here, we're comparing them to each other, P1 to P2 or mu1 to mu2. We're looking at the difference. So, so just kind of be aware that the statistic is not P1 or P2, but the difference between them, which should, in theory, be possibly 0. All right. Okay, so the first one, test for proportions. Again, the null hypothesis, null being 0. So in this case, 0 difference between the two populations. So the proportion of the first one equals the proportion of the second one. That's our H naught. It can also be written like this, P1 minus P2 equals 0. That is your H naught. And again, if you look on your yellow sheet, under hypothesis tests, two proportions, you'll see under H naught, P1 equals P2. Steps 2, 4, and 5 are exactly the same as chapter 8. Step 3 is the only thing that differs. In this case, we're going to use two proportions, z-test, and put in our x1, n1, x2, n2, and our symbol from h1. So you folks have this one here. What is the claim? Oh, first of all, is this a proportion or a mean?
Proportion.
How do you know it's a proportion?
X is given.
There's no standard deviation.
There's no standard deviation. That's the easiest way. There's no standard deviation. Sometimes we'll get confused with x and x bar. So you could say there's no mean or x bar or average, but some people get a little confused with that with x. Definitely S is only in the means. Right? There is no S, no standard deviation here. Great. So then, and also no mean. What's our claim? Claim is money in large denominations. That's my first group. So the proportion of the first group, because we said it's not a mean, it's a proportion. So P1 is less likely than small denomination. So it means it's less than P2. All right, I'm going to give you folks a few minutes to finish this up if you haven't. Just want to make sure that people were good with the claim. I'll write it out so you have it. So P1 is less than P2. And then down below here you have all of your stuff. Incidentally, it's always good to like write these out in some sort of table, or not necessarily a table, but write them out neatly so you have them. Okay, let's go over this one. So let's take a look. So first off, our H naught is always, always, always equal. So in this case, P1 equals P2. And again, you can look at your yellow sheet, and under H naught it will say P1 equals P2 for proportions. That is not my claim. My claim is P1 is less than P2. So that's going to be my H1. So I'm going to use the word support in step 5. Step 2 is my alpha. What's my alpha? 105. Great. Step 3, I'm going to do, this is a proportion. I have two proportions, so it's going to be two proportion tests, two proportion z-test. I'm going to put in my x1, n1, x2, n2, and my h1 symbol, which is less than. And you ended up with a z-score of, help me out,
Negative 3.487.
negative 3.487, 3.49. That's huge. That's a really big z-score. And then the p-value is going to be
0.00024.
Did anybody get 2.43 on the calculator? So again, reminder, you cannot have, anytime this is more than 1, you cannot have, if it's like 3 point something, 6 point something, 2 point something, 1 point something, you cannot have more than 100% probability. So there darn well better be an E negative at the end. In this case, it's E negative 4. Which means that you're going to move it over 4 places to make it what, bigger or smaller? Smaller. So here's a shortcut for that. E negative 4 means 4 zeros, then your number, 243, and the decimal place goes after the first 0. After the first one. Good? So that is clearly less than, my p-value is way less than alpha, so I'm going to reject H naught. Anytime your p-value has an E negative, it's way small. You don't even need to write it. But you do need to write this. You do need to indicate that the p-value is less than alpha and that you rejected H naught. Okay, you do need those pieces. Step 5. Blank evidence to blank claim that larger denominations of money is spent less. Okay, so it goes in those blanks.
Enough evidence to support.
Enough? Yep, enough, because I rejected H naught, I have enough evidence. And then support, because this is support there, there'll be a support here. Good. All right. Perfect. Now we're going to take a look at 9.3. These are independent. So it means that the sample are independent. You take a sample, and then you randomly take another sample. They have nothing to do with each other. The two means. Again, step 1 and step 3, the only things that change. Step 1 for two sample independent is always going to be H naught is mu1 equals mu2. That's, again, if you look up on your yellow sheet, you'll see that that's right there. Jason, give me yours for a second. Thanks. All right, so if you go to your yellow sheet and you look at H naught, which is this column here, under 2 means, mu1 equals mu2. Gives you all your H naughts. So then H1 is going to be something different. mu1 is not equal to, greater than, or less than. It's going to be one of those. The only other thing that changes is step 3. Here, we're going to use, I have 2 samples. So the 2 sample, again, me, Mr. T, 2 sample t-test. You never use the z-test because that doesn't happen in real life. So mean t, 2 sample t-test. So then here is your quiz. Let's just talk quickly about, make sure we're all on the same page about what the claim is. So what's my claim? Hypothesize is the same thing as claims. Claims that what?
The average number of sports that college offers for males is greater than the average number of sports that the college offers for females.
Great. So first off, is this a proportion or a mean?
Mean.
How do you know it's a mean?
Average.
Yeah, average. Says it right there. Average is mean. Great. So then they're saying that the average, the mean for males is what? Greater than the mean for
females.
females. So my claim is,
mu1 is greater than mu2.
yep, mu1 is greater than mu2. Perfect. The other thing is, so what? How do we get the data? We went to a college. What do we ask the college? What do we ask the college?
How many
Do you
sports
offer more
programs?
sports to males than females?
Sort of. That's a yes/no question. That make a proportion. But you're on the right track.
How many
How many what
sports
sports do you offer
for men and women?
for men? And then also we'd ask them while we're there, how many do you offer for women? So we went to 50 colleges. While you're there, you're going to ask them how many sports they have for men and how many sports they have for women. Does everyone kind of follow? So my N is 50 for both. Good? All right, so I'll give you folks a few minutes to finish this one up.